everybody to our second introductory lecture of the Cost Action Probe. My name is Anca Nemuc. I am a scientist in Romania, and I'm also the grant holder scientific representative for this cost action. Actually, I'm a scientist working with atmospheric data, active and passive remote sensing, which is the main topic of the cost action. Today, I'll be your host, as I said, and also I will start with an overview of our webinar. Last time we discussed about the instruments that are measuring the atmospheric boundary layer, and we learned about the design, the measuring principle, the products, and different applications. And this lecture is also available online in the YouTube. You can check it later on if you haven't done it already. So today we're going to discover the instrument networks. And as you probably remember from last time, we have about 30 microwave radiometers in our networks, more than 700 automatic lidars and ceilometers, more than 30 wind lidars, and more than 15 cloud radars. So now we're gonna find out why is a network of instruments important, and each of the speakers that are next will cover important information regarding the harmonized calibration, operation procedure, coverage, and other interesting things that I hope you're gonna enjoy. Also, we're gonna see what is a network offering, and hopefully this is interesting for you too. And if it is important or not to be part of those networks, there are two success stories, but also we will really love to see and hear your opinion. I would like you to feel free to ask questions for each of the network or whenever you feel comfortable. And here is the link of the pad that my colleague Henry Diemont will take a look, and all the questions will try to be answered either during the presentations, during today's webinar, but for sure we will answer it afterwards, and everybody will get their answers. Now, here is the probe work plan, and don't worry, it looks very confusing and very complex, but what I wanted to point out is that today's webinar is about the networks. Networks that are the center part of our activities and the people involved in it. As you can see, starting with the people that are measuring, and then we go further to the end users and the other requirements, instrument specification, algorithm. We have everything, but now we concentrate on the networks. And let's see why, because probably you know, but definitely today, different networks that are developed with specific objectives will present their specific products and their specific needs. But we are very interested in individual initiatives because they are necessary, because we want to respond to the specific needs. There are clear overlaps between what we're doing and probably what individuals are interested. So we want to take advantage of these overlaps to build up consistent approaches. And also we want to take care to avoid divergences. Our action specific objectives are to improve the capabilities of the existing atmospheric boundary layer instrument networks, and also we intend to design optimized geographical distribution of these instruments, and also we do this by learning your application area needs. We aim to enlarge the network capacity by integrated new networks that are not already in the big ones. We also want to enable national operators in performing observation and acquiring and deploying instrumentation to be included in these European scale networks. So with this, I would like to go to the first speaker that will talk about one very important network, the e-profile, and it's my pleasure to introduce Rolf Ruefenacht from the MetOffice Swiss. We are very happy that he accepted to make this presentation. So if you please, Rolf, start your presentation. Thank you.
Thanks a lot. So, as you already mentioned, I will have a presentation about e-profile. Just trying to go to next slide. Doesn't want to.
Yeah, just go enter or arrow.
Oh,
okay.
no, it works. Okay, perfect. Took a little time. So I'm presenting e-profile, and e-profile basically is an observation program of UMetNet, which is the consortium of European Met services. And within e-profile, the main aim is to provide near-time observation data in a homogeneous format, be it in a buffer format via the GTS, which is the standard way for the Met services, or we also have NetCDF standards for both currently operational networks, which we can distribute via FTP, and the data is also centrally archived, so there's plenty of opportunities to do scientific studies on the data. What is also important to us is that the operators try to run their observations most continuously as possible. Of course, we can have some exceptions, but the idea is really to have an operational network. And very important to mention, the networks of e-profile are all based on instruments owned and operated by local operators, and which we federate them to a common network, with having a central data distribution and processing hub, and also centralized monitoring, plus a real-time interactive visualization page, which I noted here. Currently, e-profile has two networks, one for wind profile observations, which is based on radar wind profilers and wind profiles coming from precipitation radars. Another one based or targeting aerosols and clouds is based on automatic lidars and ceilometers. Currently more than 330 units operational, and it's still growing a little bit. And in future, that means until 2023, we'll also build up a network for boundary layer temperature profiles and humidity based on microwave radiometry. So the wind network is established since many years now. You can see the stations on the right. So the red ones are radar wind profilers. The blue ones are precipitation radars, which can also provide wind profiles during precipitation events, not during dry periods, of course. And in green, we already have included a few Doppler lidars, but this is more like a pilot application, and they will be operationally added next year, probably, based also on developments made by FMI and DWD. This data is routinely assimilated to numerical weather prediction models, and it has quite a good impact, as we have seen in two recent impact studies we did. So the first line here are the radar wind profilers, and this is our precipitation data from the wind data from the precipitation radars. And the more to the left the bars go, the higher is the impact. So you see that radar wind profilers really have a very good impact, but also the weather radars have an impact comparable to the airborne observation program, which is shown here. Then second network we have is the ALC network. With this 330 units, it is spatially very dense and operated 24/7. So ALC is automatic lidars and ceilometers, just to recall this once more. And for a lidar network, this is quite unique that you have it operational 24/7 and as dense. The drawback is, of course, that ALCs are single wavelengths and low power instruments, so it's not a full lidar like in EarlyNet, but with the mass of, or the density of instruments and the continuous operation, we can gain quite a lot of insight in what is going on. So one of the primary products is the attenuated backscatter profiles, which we can get at each station in red here. This is the e-profile stations and also the yellow ones, by the way. And you can use this dense network for tracking aerosols, for example, ash for aviation, which is important, but also other aerosol particles, like for example, Saharan dust. And this is an example which we saw in February, where a huge Saharan dust event transported lots of dust over Europe. And this is a single station in Bern. So you see the dust here in the orange colors. And when you look at this quick look images overall the network, you can use this to exactly show the distribution of the dust in spatial, but also in time dimension. So altitude, longitude, latitude, and time. And in this animation, you see how the ash plume actually distributed over Europe. It started in Spain, then went over to Central Europe and finished in Eastern Europe. So this is like an example how we can use such networks for tracking. Also, eProfile will start to develop mass and extinction estimates, of course, with some uncertainty attached to it. This will be done until 2023. On the same way, we'll also improve the central calibration, which we already have in place. This is actually work going on right now. There are other applications which are not directly part of eProfile, but done by other stakeholders. For example, the PBL height estimates done in the ICOS PBL network, which we'll also hear about, and many others like for forecasting or melting layer detection, which are more research projects right now, but very interesting to see that this data can be of use for this. Of course, ceilometers were first designed for cloud observation, so we have also cloud products in the network. And the last network, which is not existing right now, but is upcoming, is a microwave radiometer network. Here the aim is to provide brightness temperatures for our simulation in numerical weather prediction. We'll then also have a central tool for temperature profiles and humidity, and also centrally calculate forecast indices. And here in the lower part, you see our schedule, how these developments shall take place. So until 2023, the full network shall be operational, and end of this year, beginning of next year, we should have a pilot network up and running, hopefully. So you might ask why it makes sense to contribute to a network like eProfile, besides, of course, of contributing to a nice product, which can be helpful for many stakeholders, but for you personally, there are also benefits of participating to such a network. I would like to mention that we have a daily monitoring in place for all networks, and you'll get email notification in case of problems. So for example, if a sensor drops out, or if we see like warnings of a sensor or bad data quality, we'll drop you an email. Then we have a monthly monitoring tool, And you can see an example for the wind profilers here. We investigate timeliness and availability, which is, but we also investigate the deviation from the mean European weather models. So here is an example for a German station, and you see how the profiles deviate from the weather models. And this is done for each station in the network. An example for the ALC network. At the end of the month, we make a plot showing the whole time series, and similarly to the wind profiler network, we also do a comparison with model data from COMS, and so the ECMF COMS model for the aerosols, and there we can use this to see on the one hand if instruments get problems, but on the other hand we can also see how model changes affect COMS, as we have seen in the past at some upgrades where we have seen quite strong differences. Other benefits is the central processing, because it might alleviate some tasks from you. So you could delegate some tasks to the network directly. For example, for the ALC, the atmospheric calibration of the instruments is done centrally. So we have liquid cloud calibration for the CL31 and CL51 instruments, and just Rayleigh calibrations for the more powerful instruments, which are done each night when conditions permit. And at the end of the month, we send out the updates on the calibration constants that we have retrieved. Then another example for the microwave radiometer network, which will be set up. The retrieval will be centralized, and also the computation of forecast indices, which is of course an advantage for the forecasters in the event of thunderstorms or connective situations. And another important or hopefully helpful tool will be the near real-time O-B statistics of the brightness temperature, which can be helpful for assisting during absolute calibrations with liquid nitrogen, because this, when errors occur then during these calibrations, you see a step in this O-B statistics, and then you will know that it might be good to redo the calibration instead of just keeping the wrong calibration constant. We also have the visualization of the data, which you can see in near real time. Moreover, other benefits are knowledge exchange. So we have guidelines for the instrument operation. We have good peer-to-peer support for technical issues. Then we have regular meetings annually. That makes up an active community, which can also help you bring more light to your work, and that has more visibility in the end. So that can also be a benefit. On the side of duties, we really insist that we get data in near real time, and this can usually be done in the native format.
Can you try to wrap up?
Yeah, it's the last slide. Sorry.
Okay, thanks.
This can usually be done with the native formats of the instruments, because we have central readers to ingest this data. You should agree to share the data at least with an eProfile and UMetNet, and agree to put in or to operate your instruments along eProfile's recommendations on a best effort basis. We aim to keep these recommendations as free and open as possible, and as compatible with other programs such as ACTRIS. And it would of course be nice if you were happy to become part of the community. And this is really the final slide, which shows some links and contacts. So if you're interested, feel free to contact me by email. Have a look at the data. You can use this for scientific purposes. Just drop me a note, and of course I would be happy if anybody wants to contribute also to the network with observation data. So thanks a lot for your attention, and I'll be happy to answer some questions now or also by email.
Yeah, thank you very much, Rolf. It was a very perfect presentation, and I'm glad that you highlighted all the benefits and how can we help what we are doing through the e-profile. Please write your question again in the pad. We will answer it at the end because we want to see all the speakers presenting their networks, and then we can have nice interactions at the end. So right now it's my pleasure to introduce Chris Walden from the National Center for Atmospheric Science in the UK. So please, Chris.
Thank you. So I'm going to introduce ACTRIS. And I'll start by asking, what is ACTRIS? We're talking about networks. ACTRIS is more than a network or a group of networks. We think of ACTRIS more as a distributed research infrastructure. It's currently in its implementation phase and plans to be a fully operational infrastructure with services and data from 2025, and it aims to be a long-term sustainable operation, so 20+ years. The strength of ACTRIS is in standardization, so the emphasis is on quality in providing harmonized data and services, and that comes through a central coordination of standards and procedures. So it's a top-down approach. At the national level, we have observational and exploratory platforms, observational platforms being the observing stations. These are called national facilities, and these are underpinned by a number of European level central facilities, notably a data center, but also very importantly, 6 topical centers which look after the different measurement modalities. So what about ACTRIS membership? ACTRIS is different from eProfile in that its participation is decided at national level. So this is each country deciding that it's going to commit resources for the long term and pay a subscription fee which will fund those central facilities. And then within those countries, the individual research organizations participate through a nationally coordinated nomination process. So at the moment, there are 22 countries that have shown their commitment at an organizational or country level, and 18 of those have member or observer status in the governing body of ACTRIS, which is the ACTRIS Interim Council. If you look at the next level down, there are more than 100 research performing organizations involved in the operation of ACTRIS. ACTRIS builds on a long heritage, 2 decades of experience from established networks of in situ and remote sensing stations for each of the components, aerosol, cloud, or trace gases, as well as simulation chambers for controlled atmospheric environmental experiments and mobile platforms. And all of this evolution through networks like EarlyNet and CloudNet has been supported by the EU framework programs and through national agencies and other international activities over the last 20 years. Networks like EarlyNet and CloudNet have been based on a voluntary association of partners. And what ACTRIS will do is to formally incorporate a subset of the sites from those networks, plus also potential new sites through a national facility labeling process. And that's to ensure that the new sites within ACTRIS all comply with a uniform set of standards. So this is again why at the network level, you can ensure uniformity of data across the network. So in terms of the elements of ACTRIS that are relevant to atmospheric boundary layer profiling, we're really looking at the aerosol remote sensing platforms, which are built on the EarlyNet basis, and the cloud remote sensing platforms, which build on CloudNet. And each of those has a topical center which looks after the standard operating procedures, starting from instrument level setup requirements, calibration, operation, all the way through the processing chain for data quality and algorithm evaluation. And these topical centers also form a link with the scientific community. So if there are new methodologies for these protocols and standards that the scientific community comes up with, the topical center can look at evaluating those, and then they can be implemented. And there are two dedicated data center units which implement the retrieval algorithms, perform the centralized data monitoring, and ensure that the data fulfill the required principles. So in terms of cloud remote sensing, if we look at the members of the ACTRIS governing body, those countries are proposing 28 potential cloud remote sensing national facilities. There are 51 potential aerosol remote sensing national facilities, and 26 of those are co-located with the cloud remote sensing sites. So there's some interesting potential there for synergies. In terms of aerosol remote sensing then, the observational platforms all involve use of a Raman or high spectral resolution lidar. Either a single wavelength is the minimum requirement, but ideally triple wavelength. And all sites need to have a sun sky and ideally lunar photometer. The difference between the minimum requirements and the optimum requirements really is whether you're running continuously or making observations on a regular basis, maybe 3 times a week on a schedule that gives you information that's sufficient to draw climatological conclusions. So the key products, we're looking at profiles of aerosol extinction and backscatter, extinction to backscatter ratio, the geometrical boundaries of the aerosol layers and their optical properties. And then when you look into more detail at the spectral and polarization information, you can start to classify the aerosol types. Then there's synergy with the photometer data that enables you to dig into some more detail on the fine and coarse particle mass concentration and more detailed spectral extinction, backscatter, and absorption profiles. If we look at cloud remote sensing, looking at the key products that we're interested in there, the classification of the targets seen by our observing systems, cloud fraction, cloud liquid water content, ice water content, and details of the properties of the drizzle. And all of these rely on a synergistic use of 3 core instruments: the Doppler cloud radar, the automatic lidar or ceilometer, and a microwave radiometer. And most sites also have a Doppler lidar. If you go on to more sophisticated setups, you can start looking at dissipation rate of turbulent kinetic energy, temperature and humidity profiles, and you can start looking at details of mixed cloud properties. So in terms of some of the detail there, the part of the difference between the minimum and optimum requirements really is the sensitivity of the instruments. So you could replace the ALC with a higher power aerosol lidar, for example, which some sites are able to do, and that gives you far more capability. The microwave radiometer, typically a multi-channel scanning instrument, will give you retrieval of temperature and humidity profiles, and having a Doppler wind lidar gives you dynamical properties of the atmospheric boundary layer. I mentioned that some sites have more than one observing entity, so aerosol and cloud profiling. So there's a strength in that synergy. This is an example taken from the ACTRIS 2 project, where the target classification from the CloudNet side and from the aerosol profiling side is merged to give you a new target classification that takes into account the aerosol types as well as the cloud targets. So what are the benefits of ACTRIS? ACTRIS provides quality assured open access data across the whole network. Through those standardized operating procedures, you're ensuring a uniformity. Instrument and procedure intercomparisons are regular campaigns operated at the sites, and those sites are also offered up to researchers to bring instrumentation for campaigns. ACTRIS also overlaps with the other networks, so there are standard operating procedures that ensure we've got high quality data that can feed into, for example, eProfile. So we already know that there are ALC data from ACTRIS that go into eProfile, and there will be microwave radiometer and Doppler lidar data set to follow. So I'll leave you just with this slide, which gives you some links for further information to the ACTRIS website, the data portal, which is hosted by Nilu, and 2 data visualization sites, which will give you quick looks from recent data. So I thank you very much for your attention.
Thank you very much, Chris. Actually, this is the umbrella for all the networks that are involved in our probe action, and it was a difficult task to do in very short time, since this is so complex. Thank you very much. People already started writing questions on the pads. Thank you very much, and we are already answering them. Please continue it. And now it's my pleasure to present Lukas Pfitzenmaier from the University of Cologne, presenting FRM for radar. Please, Lukas. We cannot hear you. Lukas?
Maybe now it's working.
Okay.
So
perfect.
a second now with switched on microphone. Hello. Excellent. From Cologne.
And we see now you in the clouds.
Yes. Yeah, it's my pleasure to introduce in a couple of minutes what FRM for radar stands for. And as Anca and Chris already just said, it's basically also under this umbrella of ACTRIS. Yeah, just want to mention that this is like a small project where a lot of people are involved. So it's not the work done by myself. So it's done with a lot of colleagues. And the idea basically is to create or to basically start some measurements towards this FRM concept from ESA, which basically tries to make understandable, traceable, and reproducible standards for cloud radar. And the focus of this project is to create ground-based measurements to evaluate the future Earth Care mission, which will hopefully be launched in the next 2 years. So therefore, basically, we look for quality checks of the ground-based radars and to see even if we can in the future reproduce retrievals from ground. And for that, we basically started a ground-based network with 94 gigahertz radars on the ground, because they use the same wavelengths as the future satellite, and we try to close gaps in the already existing ACTRIS network, and hope that in the future we can therefore basically create and develop more calibration and validation products for future satellites. So where are these few radars here? So basically we have core 4 radars, but we are trying to also cover what with Barbados a next interesting site for climate. What we do basically, we do 24/7 operation, almost near time data processing and visualization. and we try to follow the GEOM concept, which is a data format for space agencies, and hope that our data will be there, have the same format so that they are easy to use for these agencies. And the main basically big concepts or the main things we basically try to develop or doing at the moment is the receiver power monitoring, which will be also integrated soon, hopefully in ACTRIS, as well as the antenna pointing characterization. I just thought I'll give a short overview how these concepts is done. So for the power calibration or monitoring, basically it's a comparison between the distributor and the radar, which basically measure both droplets, the radar in an integrated thing, and the distributor really can measure the size drop distribution. If you forward simulate those and you compare those, and you have like the best way and both match, as like on the left side is done, so the reflectivities of the forward simulated distributor measurement and the radar, if they match each other, everything is fine. If they don't, basically you get an offset to your radar, and then therefore if you monitor that per day, per event, per weeks or month, you basically can quality control the data or the radar measurements that you have. The second thing is a little bit more complicated, maybe to get. So the thing is, we are trying to measure also as good as possible the Doppler velocities, because EarthCare will be the first Doppler capable radar in space. To have the best possibilities to compare the both measurements, we have to be sure that both, and so the antenna points exactly vertical or zenith, that we don't have any contribution from the horizontal wind if we point off zenith, because that can have a huge contribution towards the measurements, and then maybe also produces the error further into retrievals or something like that. If this thing is done using wind statistics, and that's a short example which might be complicated. So if you have two radars pointing zenith, and you have like the Ka band one, which is radar 1, where is my pointer? Here. So if you have radar 1 and radar 2, and they both point zenith, and if you basically do like subtract both of these Doppler velocity fields, in a perfect world, if they would both perfect zenith pointing, you would expect something like almost 0 meters per second Doppler velocity field. If what you see on the panel I plotted here is not the case in this case. If you correct those doing the...
Sorry, can you maybe, we need to speed up a little bit.
Yeah.
Thank you.
If you correct those, then for these two pointing radars, you can see that we get almost 0 meters per second out. So we were able to correct for those. And that's basically already my last slide. What we do at the moment we are a small radar network, especially doing these 94 gigahertz radars. We started to do some guidelines for the operation of the system. We have processing software available, do outputs in this GEOM format. And we have a very strong collaboration with ACTRIS to be the receiver power monitoring and the antenna pointing monitoring. And the aim of this network is basically foster or make this development of Cal-Val products for future satellite missions stronger. And with that, I'm finishing.
Okay, thank you very much, Lukas, for presenting. And I have to tell you that it was a pleasure to be part of this project. So any questions you might have, I probably be able also to answer. Now it's time to go to the next speaker, which is Ronny Engelmann from Tropos, Germany. Please, Ronny.
It's my pleasure to introduce you today in a very brief manner the PollyNet, a network of high-power, sophisticated, automated Raman polarization lidars that we've built during the early net time, and that is one of the networks basically implemented in ACTRIS. And I also have to say it's a network not only dedicated for the atmospheric boundary layer, but moreover for measurements in the entire troposphere and lower stratosphere. And I cannot acknowledge everyone that works in the team of PollyNet, but I have to show a few people that are a very core team in Leipzig around this. So we basically started building those poly lidars in Leipzig since around 2003. And then different institutions like the FMI or the National Observatory of Athens, they came to us and said, can we have a system as well? So we designed a project and we built several of those systems and deployed them all around the world. And then that was basically the starting point of saying, hey, we need a network where we can implement those highly sophisticated Raman lidars and have a common data evaluation scheme. So the heart of the network PollyNet is the Poly, and this is just a small schematic of the instrument itself. For those of you who know how a lidar works, it's simple. For others, it's maybe a bit more complicated. But we have a laser. We emit a laser beam to the atmosphere, and at different channels we receive on several telescopes the backscattered radiation. And in this case, we emit 3 wavelengths. It's a multi-wavelength system, and the latest system that we developed has 15 detection channels, 3 telescopes, and detects backscattered radiation at different wavelengths and polarization states. Everything is controlled via internet. The data transfer is via internet, and the instruments are made to run 24/7 and automatically. The basic products are backscatter coefficient, extinction coefficient at those wavelengths, depolarization. Most of them can measure water vapor profiles and also derive relative humidity. And we also included some channels for the detection of cloud droplet microphysics by multiple scattering. And now a brief overview to the philosophy of PollyNet. It basically is an analogy to the AeroNet. So you have one type of instrument, one data processing chain, one data quality standard. And if you want to know more about this, you can check out the website. It's called poly.tropos.de, and everything is summarized there, and you can find the quick looks there. So the data go to the centralized server, basically on a time frame of maybe 15 to 30 minutes, and real-time quick looks are generated and profiles. And worldwide, we have 14 instruments, and there's either permanent stations or campaign stations, but with the focus of 24/7 operations. And the goal of this network is that we have a research platform for scientific cooperation. We support each other, we write publications together, and as Chris already mentioned, the combination of LiDAR and AeroNet data is a very unique tool to even further discriminate particle concentrations and particle types. Data assimilation and ground truthing of satellite missions is another recent goal. In the shortness of time, I'll just give you one quick overview of the measurements. So you see here a time height cross-section over a day in 2016 from the Central Asian site in Tajikistan in Dushanbe, and this site is very much characterized for pollution of Central Asia and Central Asian dust. So you can see pollution and dust at the night of the day before. Then you have a local dust event in the boundary layer, probably a wind shear generated in the evening, and then during the day when the sun rises, the boundary layer develops and the dust is diluted from the surface, and later during the day the boundary layer collapses again. You see a nocturnal layer, you see clouds in the data, and this is just a quick overview of the data. But of course, with those lidars you can measure depolarization ratio to get ideas about particle shape, about relative humidity. The lidar ratio tells you something about absorption of particles, the angstrom exponent about the size, so everything about particle typing. And then there's also near-range profiles. They go down to 100 meters in this case. And to sum this up, I show you here again the website. And if you open the website, you see a map of all the stations. The green ones are the active ones, and the red ones are the ones that have been on campaign basis. And you can find campaign data there. And you also see that we measure not only on land, but also on research vessels from time to time. And everything is for aerosol cloud profiling and observation of cloud interaction studies. The data access is at the moment currently via the Poly team. So you would open the website, find some data links, and then you can write us an email or ask the Poly team or the station PIs, and then we go further. But in future, and also for some campaign data, we transmitted data to the ACTRIS data center, and this will be another source of data in the future. And recent research topic that we're working on is the frequent occurrence of smoke. We had those fires in North America, in Siberia, in Australia in the recent years, and the smoke layers get into the atmosphere. They are transported for a very long distance around the globe and remain there for several months. So this is one of the things that we observe. Characterization of mineral dust is a hot topic because we will have a new station in Cape Verde from the next month. So we cover basically many stations in the global dust belt, and we can try to characterize the different versions of the mineral dust. And then we do CCN and INP retrievals, especially at cloud level. We work closely together with people from in situ measurements at the surface. But what we can do is use their parametrizations and our measurements and derive CCN and INPs directly at the cloud where they matter. And then last point I mentioned here, the pollen in the atmosphere is also a topic that came up in the recent years doing the research with PollyNet. And I hope this summarizes it very quickly. Thanks.
Yes, thank you very much, Ronny. Actually, it was a very nice presentation with details, and I think it's clear for everybody what it's all about. But again, please write your questions for Ronny in the pad. Here is my pleasure to introduce Joelle Buxmann from MetOffice to present the Raman LiDAR network. Please, Joelle.
Yes, hello. Can you hear me? See me?
Yes.
I'm not sure I can control this because I'm from my iPad, because at the MetOffice we're not allowed to have Zoom. So maybe someone need to flip the slides for me. That's
I
possible.
think, yeah, you can try.
If you cannot control the slides, you can just say next slide. I will move it.
Great. So next slide. Yes, I'd like to show you our operational Raman LiDAR network, which is actually supported by a combination of operational teams, including network management and also data management and the management of the operational code, and research and development team side, which is the team I work in. We closely work together with the operational team, also engineers across service centers in the UK. Next slide. So the main function is to detect volcanic ash layers over the UK for the Volcanic Ash Advisory Center. And as you can see here, the network consists of 9 fixed sites that are operational and 1 site in a mobile trailer that is used currently for R&D purposes. And you can find details in Mariana Adams' paper. Ceilometers are also a part of our network. As Rolf mentioned already, they're also part of eProfile. And we have co-located aeronets and photometers. So here I just want to give you an idea about the instrument size and cost. So they're about 10 times heavier and 6 times more expensive than the Vaisala CL31s. And they're not running continuously. However, they have benefits such as the Raman channel and also dual polarization channel. So if you go to the next slide, you can see the laser power is also much higher, so about 1 watt, and it goes up to 15 kilometers. And we also have both analog and photon counting channels in those Raman lidars. So you can look at these specifications later in detail and feel free to ask me any questions if you want to know. Yeah, to the next slide. And as I mentioned, the main purpose is to support the Volcanic Ash Advisory Center London, which is actually based in Exeter at the Met Office. And Iceland is part of this area. So volcanic ash is a focus here. And our ground-based network is part of a combination of satellite-based observations and also model input for them to give guidance to the Civil Aviation Authority. To the next slide. So here I want to show you a more detailed case of a Saharan dust and biomass burning event during the ex-hurricane Ophelia storm. And this was brought to us to the UK, as you can see here in the MetOffice Global Model Dust Forecast of the AOD, quite high AOD values. And the benefit of the Raman lidar is shown that we can directly retrieve the dipole ratio and backscatter. And here you can see range and molecular attenuated signal across 4 locations in the UK. And the lidar volume linear depolarization ratio, where, for example, in Watnell in the evening, that's in the evening of the 15th of October, you can see a layer at around 2 kilometers, which is quite red. So high depolarization ratio, which means non-spherical particles. Yes, there's Simone, thanks. And this is an indication for dust. So if we go to the next slide to show you the whole benefit for this case, we can actually, we are able to retrieve the extinction and backscatter profiles, and then also the particle depolarization ratio and lidar ratio from this using the Raman channel. And in addition, because they're co-located sun photometers, we can also separate the extinction profiles for coarse and fine mode aerosols. And then using specific aerosol densities, we can retrieve mass concentration profiles from this data, as you can see here in the last plot. And this goes up to about 400 microgram per cubic meter. And then if we basically plot the lidar ratio against the particle depolarization ratio, this gives us also an indication for the classifications. This scheme is based on a paper from Gross et al., for example, for this 355 nanometer. And this, we're using this actually as a web application within the MetOffice for our forecasters, so they can, for a particular profile, they can choose the time and the height, and then they get all these retrieval products and an indication of the particle, what type of particle it is, and also the mass concentration. And then go to the next. Thanks.
Sorry.
Very much.
Okay, thank you very much. Joelle was a very quick, and you covered most of the things that you were doing there. Thank you very much. Now let's see, our next speaker is I think, Jerome Tarniewicz from France, presenting the ICOS network. Please, Jerome.
Thank you. Hello, everyone. I'm Jerome Tarniewicz from ICOS ATC. ITC is the Atmosphere Telematics Center of ICOS. ICOS, in a few words, it's a distributed European research infrastructure. ICOS conducts standardized, high precision and long-term measurements to better understand the carbon cycle. It is the European pillar of the global greenhouse gases observation system. And in 2021, it's officially 12 countries, plus Poland and Spain soon. And it's also 140 measurement stations on the ground. Now the ICOS network, the stations are coordinated and run by the ICOS national networks from the countries which are involved in ICOS. There are 3 distinct domains, the atmosphere domain in red on the map, the ecosystem in green, and the ocean domain in blue. And in each domain, there is a thematic center which coordinates the observation, the processing of these observations, and supports the station also. The observations are coordinated by the head office, and the Carbon Portal is in charge of collecting and distributing the ICOS data. This is the list of the ICOS K product. There are 4 levels of data products. The first one is raw data, and it is not mentioned here. The level 1 is for NRT data, and RRT data means the day after for ICOS. Level 2 is for final products in ICOS, and these level 2 products are products which have been quality controlled by the station PIs. And finally, the level 3 products are the more elaborated data products. Concerning the access, all the data are available in an open and transparent way according to the FAIR principles. User can access those data through the Carbon portal. Now, ICOS and BLH. ICOS supports the Atmospheric Boundary Layer 8 Testbed Initiative with ACTRIS and eProfile, IPSL and IRIS. The goal of this project is twofold. First, it is to demonstrate the performance of automatic BLH retrieval with Stratfinder and CABAM algorithm. And then in the second time, it's also to formulate a recommendation for application across diverse network, in particular for ICOS atmosphere domain, where the BLH is a mandatory parameter for a class 1 station. On the right of the slide, you can see a map of the envisioned BLH network for ICOS. And all ICOS class 1 station will be equipped with an instrument and data will be accessible through the Carbon portal as for the other ICOS product. So now, why is ICOS interested into BLH sounding? We know for a long time that dominant uncertainties in inverse estimates of regional CO2 fluxes is related to model errors in vertical transport within the PBL. It has been demonstrated that the error in CO2 estimates can be reduced when the true value of the mixing height is known. And ICOS is also interested in the BLH sounding to evaluate PBL schemes, for example, to better assess the vertical mixing. It's also BLH an interesting parameter for the sampling design of flash data. For example, it's good to avoid the BLH transition periods when you apply the upwind downwind gradient method for flash sampling, especially for C14 measurements. At least the PBL is important for urban surface parameterization, like we are going to see in the next slide on POL. So what is POL project? It is a European H2020 project for developing greenhouse gas measurement in cities. It is led by ICOS, and in this project, 3 cities have been selected for POL. There is Paris, Munich, and Zurich. In this project, existing measurement networks will be enhanced and combined also with remote sensing approaches. In particular, Doppler wind lidar will be deployed within existing eddy fluxes and atmospheric in situ sites. And using these networks, PBL schemes will be evaluated using wind profile and PBL8. And also sensitivity studies will be conducted on model greenhouse gas emission when nudging a PBL model. So that's all for POL and that's all for ICOS, and thank you for your attention.
Thank you very much, Jerome. ICOS is one of the biggest network and very important networks that are dealing with the AVL instruments.
Thank you.
So now let's go to Fred Meier from TU Berlin, observing the urban AVL in urban environments. Please, Fred. I know that he was on earlier. Fred, can you hear us?
Fred? Oh. Are you unmuted, Fred? Fred.
Okay, now, now
okay.
I find the right button. Yes, hello together. My name is Fred Meier. I'm from the Technical University of Berlin, and sorry, I have no camera on board, so I can only talk to you without an image. And the topic now is urban networks, and yeah, it's also very important, as we saw on the last slide, about the POL project. And now today we find more and more ABL measurements in cities. So this is really good, because the cities are very different in size and climate, topography, and of course building density. And so Simone and I started to compile a list of cities, and you can see on the right side the map for Europe. Most of the cities have at least one ABL profiler, and but we also have cities with multiple profilers and sites. And a comprehensive knowledge exchange with this, between these urban networks, so a network of networks, is the goal of the probe subgroup on urban environments. And if you are interested in this exchange, please join the urban subgroup. And the next slide asks the question, why should we observe the atmospheric boundary layer in cities? Yes, of course, we should observe the so-called urban boundary layer, because most of the world population will live in cities, and the urban boundary layer defines the air we breathe. So the urban people are especially exposed to the climate modifications like the urban heat island, or in this case, the urban boundary layer heat island. And also urban pollution island or extreme events like flooding and of course global warming. But in fact, for sustainable development of cities, for sustainable urban development, we need a more detailed understanding of the urban boundary layer. And this knowledge is still limited, and therefore we need urban networks for ABL measurements. And especially in urban settings, it is important to understand the influence of buildings and human activities on the ABL dynamics. So we need variables, atmospheric variables, which are helpful to understand feedbacks on the local climate and air quality. So this includes ABL, height, that's very important, cloud dynamics, and of course the profiles of air temperature, humidity, wind, turbulence, aerosol, trace gases. And here on the right side, you can see a very nice example on how cities create their own clouds for Paris. This paper is recently published, and you can see the different atmospheric profiles for turbulence intensity, and also the differences in the boundary layer height between London and the rural side. But the biggest challenge is of course to consider the spatial variations in the urban boundary layer because of the different land covers in cities. And so this brings us to the next question, which is very important: how to design urban networks for ABL profiling. And this includes more questions about network density, sensor selection, sensor placement, and many more. Yes, and at least you have to consider the scale of interest. So that means, do you like to look at the difference between the city and the rural surrounding, or are you more interested in the differences between land covers like parks or residential areas? And you always have to keep in mind the sensor source area. For example, if you look at the urban plume, you have to keep in mind the predominant wind direction. And here on the right side, you can see a very nice concept for the ABL profiling strategy in the Paris region, which is foreseen for the field experiment within the Urbisphere research project. And further, we have a benefit in cities. We have relatively high aerosol concentrations. This gives us relatively strong signals for certain kind of sensors. But we also have a lot of challenges like site access, permission, site locations, finding site locations above canopy, and interferences. For example, this is a problem for the microwave radiometers. There might be a problem. And yes, the last slide. There are many applications for urban data related to air quality, weather, climate, or air mobility. And we need this observational data for process understanding, model development, model validation, atmospheric forcing, or data assimilation. And that's why we, the end users of these urban data has to communicate their needs for these measurements in cities. And I think this is kindly a missing link, so that the end users have to communicate their needs. And this is also one point in our urban subgroup. And if you like to join, please write us an email. So the urban network is not a network like the networks shown before. It's focused on the knowledge exchange between networks. Okay, yeah, that's all. Thank you very much.
Thank you very much. It looks like I have a little bit of a problem with the internet. I'll try to see if it works. So now we're going to the user stories. It looks like I'm also potential candidate for this. And okay, so our journey in becoming an ACTRIS partner, and also I will make some presentation about our new experimental site, CO Terra. A short history, we started in 2004 with our first lidar in the remote sensing. We had a lot of steps going further into the early net site, and then AeroNet and other networks. What I wanted to point out, apart from the fact that we had to access several funding opportunities, that the most important was the expertise that we gained from the collaboration through the network, and also very important, our collaboration with the research team. It helps us a lot, and now we can say that we are partner in ACTRIS, and this year we will also become, as a country, an ERIC partner, which is a very important thing, as our colleague Walden presented today. Now the team, we started in 2005 with 5 people. Now we are 19, sorry. And we are experienced engineers, physicists, mathematicians, computer programmers, but also we have new people, 5 PhD students working with us, that hopefully will stay with us. We have a lot of instruments that are implemented at both sites, Rado and Mars. As you can see, the one highlighted are the part of the networks that were today presented. And we gained not only the expertise on what to buy to be able to get a very good scientific result, but also how to operate them, how to calibrate them, and it helps us a lot. We are contributing right now both at the Earth observation program of the European Space Agencies, implementing several projects together with partners in Europe, but also we are national facilities in ACTRIS in 4 of the parts: aerosol, cloud, reactive gases, and aerosol in situ. And also a very important part is the lidar calibration unit, which is the topical center for aerosol remote. We also have big plans in developing our Romanian network, ACTRIS. So what we learn through the networks, we go further and transfer the knowledge and implement new sites in Cluj, Iași, Eforie, and the new site Galat, our site being in Magurele for aerosol clouds and trace gases. The new experimental site is called Mars. Magurele Center for Atmosphere Radiation Studies. We had to make a movie this March when it was finally finished the implementation of the CO Terra. This movie will be available for the YouTube channel and also in the Probe Coast Action website, and you can definitely visit. Hopefully during the next years, you will be able to physically visit our site. So thank you for your attention. And I give the floor to Davor Tomšić from Croatia to show us their site and see their story. Please, Davor.
Yeah, thank you, Anca. First, as we can see, we see two, let's say, a little bit different approach to participation in international collaboration. From Romania, you see from a more scientific view, scientific background, and we are approaching more from meteorological part or meteorological service, which is running more classical networks and classical measurements. So we started, let's say, just to move this. Okay. Yeah. As we as a meteorological service started with a network of classical measurements in mid of 19th century. So our starting point for joining the, let's say, profile network or UMetNet community was at the beginning with two radio sounding stations, which we have in Zagreb, Maksimir and Zemunik measurements from, let's say, mid of 20th century and the beginning of 21st. And dedicated to the upper air measurements, we acquired one mobile sonar unit with sonar up to 1,000 meters, which was starting point to join the e-profile community. At 2010, it was our first participation in Improve meeting in Payerne in Meteo, Swiss, and I found our network plan from that year. That was idea to build a 5 location in Croatia for upper air measurements. And in the meantime, let's say 11 years after that, we are somewhere toward the realization of this plan. During the 2017-18, we are manageable to acquire first 2 ceilometers, which were starting point for implementation later in the network. And during the 2019, with Interact project Adria More with Italian side, we acquired one LAP 3000 wind profiler, which was placed in Dubrovnik on the Adriatic coast. During the next period of time, just quick showcase actually from where started and what was the reason why we could say that we have success in such kind of international collaboration. I started in 2010 with the EABO program with air measurements, and then with eSurfMar, which was later result with adoption of one UCAV station, and after that we plan to deploy 6 oceanographic buoys in Adriatic with additional 25 automatic weather stations for measuring sea temperature. And with e-profile now we are with one sonar with wind profiler and 2 ceilometers, but during this year we're planning to make installation for one Doppler lidar, microwave radiometer and additional wind profiler, which will fulfill our goals from 2010 and also be included in future e-profile network. I also managed to be special consultant for University of Split, which also during this year finished a tender for one little bit bigger sonar, which will be deployed during the end of this year and the beginning of next year. And also have task from e-profile to try to incorporate 6 additional ceilometers from the air traffic control on Croatian airports, especially on the Adriatic, which can be integrated in the profile network, but for now that's a little bit on the standby. Also, there is the contribution from participation in a working group for radio sounding and instruments, which also benefit to get more information from international community. Next slide. What was the real benefit participating in this case e-profile meeting? After the deployment of wind profiler in Dubrovnik, also we have meet real situation. We have very, very heavy lightning thunderstorm during the summer in Dubrovnik when we have damaged the wind profiler, some signal processing unit and some other parts were damaged. And regarding to experience from other members from the program and communication with producers, we managed in quite capable time of 1 month to replace all damaged components and to be running regularly and running every day since this incident. Also, during this winter, we have a situation with the ceilometer in Zagreb situation, when we have drop of laser energy to 0 and we lost the power. In the meantime, we have communicated with Jacqueline, who is the coordinator in UMetNet e-profile network. We also heard that was also one situation similar in the Netherlands. Also have communication towards the producer who sent us the replacement laser part completely. We have changed it on our own because it was almost impossible during the winter that they traveled to here and to replace it. And we managed practically in 12 weeks to start again with measurements. Also, one of the benefits is that we could see that during the autumn of 2020, we have managed to register the forest fire particles over Europe from US forest fires. So you always can benefit from such kind of collaboration and measurements which you perform. Also, some plan for future and to see what we have on the present. My starting point was also to try to build the upper air test bed on the Adriatic coast in Zadar when we have radio sounding. That was starting point from 2000. That's all what I have from documentation and a little bit more. But nowadays we have finished whole projecting documentation and let's say now in a phase to fighting for funding to let's say establish one nice location where we could put a lot of different upper air measurements instruments and also try to through this collaboration between e-profile ACTRIS also add something which I think I didn't plan at the beginning. So I don't know, maybe we could achieve even more what we accept through our collaboration. So that's from me. Thank you.
Okay, thank you very much, Davor. And with this, I have to thank all the speakers of today's webinar for their presentation. And I had to switch to my iPhone, I'm sorry, because I don't have any more connection to the internet in here. But definitely I've seen that people were writing questions on the pad and there were also answers from our speakers. Now is the time, if you would like to ask question, it's fine. Please take the floor. If anything, if you really want to ask, don't be shy. We still have like 10 minutes to talk about. I don't see any raise hand or something. Do you see, Simone?
Henri, can you share some of the key question that is stated on the pad?
Yeah, there are very technical and specific questions for every network, but also some general questions like how to join, instruments included in the network, how to retrieve measurements from the network, and what's the geographical coverage of the networks. I have a general question for the speakers. Since we are, Simone and I are leading work group 1, which is focused on the stakeholders, and that's what are the intended stakeholders for the different networks. What are those networks intended to?
You have to ask someone specific.
Yeah, I don't know if anybody wants to reply, because I think that we have different groups of people attending here. The ones that wants to join a network because they have an instrument, but probably most of them are interested in downloading the data and studying the data. So maybe we can address also this group of stakeholders and users.
But I think it was very nice to see that we have, with the different types of network, we really address a range of stakeholders. So we have the farm radar network is more towards satellite validation, and they tailor the products and the file formats directly for this type of community. You have in ICOS, it's about the greenhouse gas assessment. You have in ACTRIS, I think the stakeholders for ACTRIS are very, very broad. Maybe different people are interested in aerosol profiling products or cloud products. Maybe is Rolf still here? Maybe you can comment on where do you think there's overlap between ACTRIS and eProfile, and where do you see you're serving different stakeholders?
Okay. Maybe another question for all speakers is always about this is if they found from somebody else presentation that the stakeholders that there can be other stakeholders different from the ones that they already thought about.
Okay.
Okay. Shall I give a quick answer to Simon's question? So eProfile basically is mostly interested, as I already mentioned, in real-time data provision and possibly in providing it around the clock. ACTRIS, on the other hand, is a bit more targeting the scientific community, but we have many things in common, and especially for the upcoming microwave radiometer network, we are already very much in collaboration with ACTRIS to define standards which match and to have a data format which is the same or at least very close. So I think it's lots of synergies, but it's not completely the same. But many operators might want to join both networks actually.
Yes, and I think that's a key aspect where probe also comes in, because I mean ACTRIS and eProfile is already working closely together to ensure that the standards and operating procedures and formats are compatible between these two very key networks. But within probe, I think we're working towards increased or supporting this knowledge exchange, and also to see how the two networks can work together towards more advanced product development. So you mentioned automatic calibration and correction procedures, and then what we have heard also in context with this ICOS a network for avial height detection. So to see how the network activities can work together in developing advanced products, I think is one of the key objectives of the probe action that we see here. If there's not another question, I have another one for the user story, the success stories that we have heard. So you mentioned a few points that where you think that there's the biggest benefit on joining a network. Can you explain to us how it is, how it starts when you think, okay, I have the surface measurement network and I want to enhance my upper air observations? How do you approach this? How do you choose which network to contact, and how do you find out your information?
I can answer this. This is Anca. What happened, I mean, from our experience, what we did, we looked up to see what are the networks available at the point. It was about lidar, let's say. But recently, one of our colleagues that joined us wanted to be part of the radiation measurement, let's say. So it's a different network that we haven't talked about here, but it's also the same principle. First, you take the information from the website, but I think the most important ones are the meetings of the network. There you can definitely see the procedures, definitely see how the people are handling the instruments, how the people are handling the data. And there's the most important point that you have to get to see if you have people available, if you have expertise available, if you can afford to buy those instruments, because there you see what are the range of prices of the instruments that are involved in the network. So yeah, I would vote for definitely get into the meetings of the network to see the insights and to see if you can go further on. That was the question, right?
Yes, very useful information, I think, for people who consider joining or are interested to acquire new observation capabilities.
Could I also add something? And
yes.
I think it's interesting that what Anca said, she and Romania had developed their path through more, let's say, scientific community. We as a member of, let's say, UMetNet and meteorological service go more through the meteorological part. So it's nice that, like, not in the end, this time we joined together through these international programs and could share our benefits and knowledge together. And that's, I think, the most important thing these days, especially with collaboration between different platforms and different persons who are involved in these programs. Also, from my point of view, we start, let's say, almost from zero. And the great benefit is that all meetings are practically held on locations with meteorological observatories or places where is deployed equipment and where people who actually doesn't have any experience with it, doesn't see or anything know maybe about these instruments, in meantime have possibility to see, to try to get some information and to talk with people who had experience. And that is very, very good, especially in these days when, okay, you have a lot of information, but information from people who had these instruments in their hands and know how things works, it's priceless. And that's, I think, that's very, very good feedback from this integration of all services and interested party in such program.
Okay, yeah, that's very nice. Thank you for this comment. And I think it wraps up very nicely also with the comments of Henri that, you know, we are trying to address different types of stakeholders. And as you mentioned, there's the scientific community and the operational weather prediction in National Meteorological Services community. And if we enhance the exchange in the knowledge. We don't have to reinvent the wheel all the time, but we can move forward together much more faster. So very nice wrap up. With this, I would like to close the webinar of today. I would like to thank Anca for moderating the whole webinar. I would like to thank all the speakers for bringing together this vast amount of information and presenting to us. It was very, very nice to see. And to close, we would like to ask a little bit of feedback from the audience. So if you have another, Claudia promised it will be very quick. So if you have another minute to stick around and ask a few of our questions, it would help us to improve our webinar series and try to connect with you as a user for the probe activity. And we would like to invite you to join our next lecture, which will happen in the autumn period. So we make a little break over the summer and you will hear from us very soon. So we want to talk about advanced products in the next introductory lecture of the probe cost action. So thank you very much and please answer the questions and see you soon.